Hi everyone, this is Carl, and this is AMBA 600 MBA Fundamentals, Stat 689 Excel and Statistics Tutoring Forum. And what we're going to go through today is basically quantitative reasoning and interpreting statistics, kind of understanding the story behind your data and how you want to present it when you're giving a certain output and you're asked to kind of summarize that output in text form, basically writing a summary of the data. It's one thing to calculate data, to create charts, to create additional variables to help you summarize the data. Mentally knowing that, but explaining it to folks that maybe not be well versed in the concepts, may not be well versed in the subject matter of the data that you're analyzing, or just may not be that quantitatively adept at understanding, especially when you're getting complex forms in the sense of scatter plots, in the sense of line charts that have an accompanying histogram. Those are more complex analyses, but in terms of just at the core of it, just understanding how to tell the story of your data. So, what's the story? What is the story? Trends, frequencies, outliers, missing values. So with respect to trends, it's pretty cut and dry. When you have trends, costs go up, expenditures go down, national debt's increasing, those kinds of things. Those are pretty easy to kind of infer and to kind of use as a launching pad for further discussion or to validate other arguments. Frequencies, it's much the same. If one value is more, such as in sales, if one brand of a cereal is the highest seller in this grocery store, then you can infer and you can definitely kind of summarize that it's a bestseller, and so then to proceed going towards other reasonings as to why that might be the bestseller. So it's a lot of kind of telling the story in that way. And outliers is a good one. With respect to outliers, you have certain data points that do not match and fall in step with other data points. And that's a key point to kind of show, because that may lead to some questions about your data set itself. If there's enough outliers, if the outliers are very dispersed, then that might cause you to kind of investigate your data further to see if there's any issues with it, either in its construction or gathering. Missing values, that's an important one to include because, for instance, if data, and it's probably a pretty good rule if you work in data, if not already, is there is never any clean data. Data is very messy in terms of values missing and values kind of being corrected. So with missing values, if, say, for instance, you have the SAT scores, you have a sample of students, 500 per se, and you have the SAT scores, but you only have the SAT scores for half. The others are blank, either for some procedural error or the testing agency couldn't produce them. So you only have the SAT scores for half of the students who took the SAT scores at that particular location. So that affects your interpretation, because you have to take that into account to say if the half scores scored really high, you can't summarize the entire cohort 500 as, okay, then they must all have gotten those as high a score, if not better. You can't do that. There's limitations in that. So wanted to point that out, that a lot of data is messy, and you will have missing values, and not particularly with the kind of assignments in this course, but just understanding the reasoning behind it. That the understanding that as you tell your story of your data, to note the limitations of it. That is, you cannot make declarations per se. It's more making assumptions and summarizing with caveats based on these kinds of things, outliers and missing values. So what we're going to do is we're going to jump right into Excel just to kind of give you a sense of what I mean. And a point in here, you can see here, we're at our table again. Categorical variables are variables that kind of have a finite number of values. And I chose one, particularly the order priority. As you can see here, there's only so many order priorities. There's these values, 5 in all. Low, medium, high, critical, and not specified. That's it. Those are all the possible values in this data set of about 8,400 records. So, the histogram is probably the most appropriate analysis for this. because it allows you to see, which one's the high, which one's the low, and you can make a whole series of inferences by this, as opposed to, so why is critical the lowest? Well, is it because that some were not as urgent? That might be the case, but qualitatively, maybe critical, just similar to FedEx or the post office, critical might be the most expensive option, and as opposed to low. And high, why is high the highest? Well, that could speak to the need of the products, speak to the need of the request for a high priority mailing, or it could be a result of maybe there is a special discount going on with respect to the order quantity or the actual order itself, and then getting free shipping, discounted shipping, those kinds of things. So that could lead to some of this unique aspects to this particular output. The second output I wanted to show you is the scatter plot. As you can see with the scatter plot, I've scattered plot order quantity and sales. What does that mean? That means this column is X. X is across here. So the order quantity is here. As you can see, 0 to 60. That means the max was somewhere around just a little bit about 50. And Y is the sales associated with it. So earlier we were talking about outliers. And so as you can see here, there's one outlier in this data set that for an order quantity of 13, there was 89,000 in sales. So what does that mean? And that helps you kind of, these different presentations really help you piece out and pair out kind of outlier issues or unique findings such as this. So why would, when everything else seems to be linear in the sense as the order quantity increases, the cost increases. That makes sense. The more you buy, the more it costs. But this outlier could speak to either an issue with the data or an issue actually in the context of how this data was collected. Because if there is a, say, high-priced item that they sold, that could explain why this is so low. So there's several other things to take into account, and the key point we want to drive home is that first piece in understanding your data, and after the presentation piece of it, is to kind of show you how the story can change depending on your chart, and it can change depending on your presentation. So I just wanted to emphasize that, and we wanted to emphasize that, and we'll be having additional videos kind of showing you different interpretations of data that you can do, different variables, so that you understand as you get, and it takes practice, that as the more you kind of get the hang of this, the more you can understand it, and the more you can delineate between, okay, is the bar chart the best option for this particular variable? Is it categorical? Or is it continuous? And what does continuous mean? It means it is not, it's never ending, it's infinite. In terms of, like, for sales, sales doesn't stop. If someone sells 100 units, there's going to be a corresponding cost that increases along with that. So categorical, there's only a finite number of values, or continuous, that it is endless in theory, but not practically, but in theory it is endless. There's no ceiling to the amount of sales you can make depending on how much quantity you're able to sell. So the type of variable is very important to remember when thinking about data sets in the presentations, that would inform your interpretation. So in short, I just want to emphasize that if you have any questions along the way, please let us know, and we'll be posting additional videos based on your feedback, based on your questions, and we also will we are available throughout the week by email, through the posting of the conference. So just please let us know if you have any questions along the way. All right, thanks so much. Bye.